Hello students, now we are going to discuss about writing Verilog code for full adder both in data flow as well as structural modeling, okay, or gate level modeling. Okay, this will be a gate level modeling. Okay, and then I will be writing program in data flow modeling also. Okay, the introduction and the symbols for the data flow modeling is discussed in half adder Verilog HDL program video. Kindly go through that video also, okay, in order to understand this clearly. So this is the next step. Okay, here I will be teaching you how to use wire. Okay, so what are the signal I should declare as a wire? Okay, that I will teach in this particular video because there are a lot of intermediate signals you can see. So in this diagram, this S1, T3, T1, T2 all are intermediate signal, okay, which is not connected to any of the inputs or outputs. Okay, so this we call it as intermediate signals. This we call it as intermediate signals. So what I should do if I have an intermediate signal in the diagram? Okay, that is what the important thing you should understand here. So first of all, I'll tell you how to write the program in data flow modeling. How to write the program in data flow modeling. So I can write in 2 steps. Okay, in only 2 lines I can complete the code in the case of data flow modeling. And later I will discuss about how do you write the program using gate level modeling. How do you write the program using gate level modeling? Okay. So the first thing is data flow modeling. So first of all, I need to write the first line. I need to start with module. So I'll start with the keyword module. And next to module name, I can simply write FA or full adder. So whatever name you wish to give, you write. It is an identifier. There are some rules for identifier. Okay, follow the rules and write this full adder. Okay, the name here. And then I need to write the port list. The port list can be written based on the signal which can be acting as an input to the full adder and which can be acting as an output from the full adder. So those signals only can be written as port list. Okay, the signal, if you see S1, T3, T1, T2 is not under the port list. Why? Because these are all the intermediate signal. The output of the first XR is connected to the second one. Okay, this will not appear at the outside. Okay, so I don't bother about what is the value of S1 at the outside. Okay, this we call it as intermediate signal T3, which is not connected to the output directly, so I don't bother about this. This is an intermediate signal which will be the output of A1 gate and which will act as the input of O1. Okay, so T1 is one of the intermediate signal and T2 is one of the intermediate signal. So these are all the intermediate signal. In the previous program, these intermediate signals are not there. Okay, if you go for the bigger designs, in this case definitely there will be some intermediate signals. You should understand how do you use those intermediate signals and how do you declare it and why we need to declare it. Those things you should know. Okay, now if you see port list, those intermediate signals should not be there in the port list. In the port list, the signal which is acting as an input to the design and then which will be acting as an output from the design. Okay, those signals will be in the port list. Okay, so I'll write that first. So I have A, B, C in. Okay, these are all the inputs and then some C out. So these are all the signals in the port list. Okay, now these port list, the signal in the port list should be declared. I already told you that there are only 3 ways to declare the signal in the port list. So one is input, another one is output, and last one is in out. So input means the signal which is acting as an input to the design. Output means the signal which is acting as an output from the design. In out is a bidirectional signal. In the case of full adder, there is no bidirectional signal. Okay, it will be having inputs and outputs. So this A, B and C, these are all acting as an input to the design. So I am going to declare that as input. A, B, C in. I have written like this. Next, the sum and C out will be acting as an output. Okay, it is acting as an output from the design. So I will declare that as an output. See, all the keywords, module, input, output, these are all the keywords should be written in lowercase. Okay, so sum comma cout. So each and every line I am terminating, okay, using semicolon. Okay, you should not miss that. Okay, each and every line I am terminating using semicolon. Okay, now how do we write the statements? So in the case of Dataflow modeling, here I am going to write the program in Dataflow. In the case of Dataflow, I need to know what is the Boolean function for sum. Okay, the sum can be written in two different ways. Let us write the equation directly. So sum equal to, I can write as A XOR of B XOR of Cn. It is one, I can write the expression like this directly. So as per the diagram, there are first thing is S1, which is the intermediate signal, which is A XOR of B, and then sum equal to S1 XOR of Cn. Okay, so S1 is A XOR of B, so it will be equivalent to this. It will be equivalent to this. Okay, so it is written as intermediate signal. I can directly use this statement also. Okay, for writing the program in Dataflow. Okay, next, what is cout? So cout is equal to AB BCin ACn. So this is the expression for cout. Okay, this is the expression for cout. Okay, so I can directly write the program by using this statement and this statement. Okay, in two lines I can complete the code. So otherwise I can use this and this for writing the program. Okay, it is up to you to decide which statement I can use. So if it is a Dataflow modeling, I need to use continuous assignment statement. So I'll start with assign keyword. Okay, I'll write the target net, which is equal to Boolean expression. Okay, I'll be writing the Boolean expression, but for writing the Boolean expression, I'll use different symbols. I'll not use the XOR symbol, which is used in the digital logic. Okay, I need to use operator, which is available in the Verilog. Okay, so for XOR operation, I'll use cap symbol. Okay, this is for XOR. For AND operation, I'll using ampersand. Okay, these are all the two things I need to use. Remaining thing I can use bracket. Okay, if I have multiple computation to be done, I'll be using brackets. Okay, so first thing is I'm going to write the statement for sum. So I'll write assign sum is an output. Okay, if you declare it as an output, then only it can be written on the left hand side. That is the thing you should remember. Sum will be equal to, here I written target net. This should be declared as output, then only I can write here. If I am declaring this as input and if I write it on the left hand side, it will throw an error. Okay, so this is supposed to be declared as an output. Whatever state variables which you are writing here at this point to the left hand side, it has to be declared as output, because I need to assign some value to it. Okay, so next, sum A cap, which is XOR operation, B cap Cn. So this is a program for this is a statement which I can write to calculate sum. Okay, similarly the next line, assign cout is equal to, within bracket I'll write A, here it is A and B. Okay, I'll use ampersand symbol, B, close the bracket, and this is OR. For OR I should use a vertical bar, which is above enter key. The key which above enter key, you need to use a shift and press it, vertical bar. Okay, don't use forward or backward slash, that is totally wrong. Okay, you should not use forward or backward. Okay, it has to be a straight line, vertical straight line. Okay, you can find it. Okay, above enter you can find this. So A and B, vertical bar, and then B ampersand Cn, close the bracket, vertical bar, A, okay, open the bracket, A ampersand Cn, close the bracket and end it with semicolon. Okay, A and B, or B and Cn, or A and Cn. Okay, that's all. Within two lines I can complete the code. I will write end module. I can write end module. Okay, so I hope you can understand this, how to write the program using Dataflow modeling. So next I'll explain you how to write using gate level. Before that, I'll tell you how the sum line can be written in different way. This can be written in using these two statements. If I want to use this two statement, the S1 signal is not declared anywhere. Declaration part, it is not there. So I am supposed to declare that, okay, as a wire. So wire S1. Okay, wire S1. Okay, wire S1 is an intermediate signal. Okay, if I need to use. Okay, for this program it is not necessary. For this program it is not necessary. Suppose if you want to write this two statement, I'll be declaring that as wire. Okay, wire S1, and then next line should be assign S1 should be equal to A XOR of B. So this A XOR of B calculation is available in S1 now. Now again I'll write assign sum equal to S1 XOR of, sorry, this S1 XOR of Cn. So this single line program can be written in these three lines. Single line program can be written in these three lines. Okay, so it is up to you to decide, because S1 is acting as an intermediate signal here. So this signal will not be available in port list or port declaration. Okay, this intermediate signal should be declared as wire. Wire is one of the keyword which can be used to declare intermediate signals. Okay, so now I'm going to clear all this program, because I'm going to teach gate level modeling. So kindly understand both the programs. You're supposed to use gate level as well as Dataflow for writing the program. So I'll clear all this. If you want to note on the program, just pause the video and note it down. Okay, so erase all link. So now next thing is I'm going to write the program in gate level. In the gate level, we have already discussed, these are all the gate primitives. So these are all the gate primitives. If you see XOR, so this is what I'll use, the XOR and AND. Say XOR, so how it is written, XOR is a keyword, okay, and then optional instance name. The instance name which is written as GXOR, which is optional. This can be written or this can be ignored. So I write G1 within bracket. Okay, O is an output, I1, I2 and so on up to I8. The number of input is depends on your simulator. Okay, so and the diagram which you have, okay, based on that only the number of inputs will be decided. It need not be 8, it can be 2, it can be 3, it can be 4, it can be anything, whatever it is needed. So if you see AND, instead of XOR, just put AND there. The same syntax is there. But if you notice one thing, the first location, what is there? Output. Always I can write the output in this first position. Okay, following the output, only one output can be written. Following the output, I can write the list of inputs, whatever it may be. Okay, it can be 2, it can be 3, it can be 4, anything. Okay, so following the output only I can write. In the case of gate primitive, if you are using gate primitive, it is a syntax. It means it is like a formula. In that, this can be written only in this way. Okay, so XOR is a keyword. Any instance name can be written, which is optional. Okay, if you want to write that, or if you want to leave that. Okay, it is up to you. Within bracket, first thing is output, comma, then inputs. Okay, then we need to write inputs, the list of inputs, the comma separated list of inputs can be written. And finally it has to be terminated by semicolon. Okay, so this I'm going to do. Okay, okay, so I'll write line by line. I'll start writing here. So module is a keyword, module name within bracket, and these are all the port signals. I would write all the port signals. For data flow and structural or gate level modeling. Okay, this is my gate level modeling. The module line will be same, declaration will be same. Okay, there will be no change in it. Okay, so module FA, A comma B comma C in comma sum comma C out. These are all the port signals. The next step is declaring the port signals. So these port signal can be either declared as input or output. So first I am going to declare it as input. We have A comma B comma C in. and then output will be sum and cout. Okay, I'm just moving fast because already I discussed about this in this video itself. So output sum comma cout. So now the new thing comes. So if you want to write the program using gate level, each and every gate will be implemented separately. So these intermediate signals are needed to connect the output of this XOR with this input of this XOR. So this intermediate signal can be used to connect the output of this gate with this one. So this intermediate signal will be used to connect the output of A3 to input of O1. So this intermediate signal will be used to connect the output of A2 to input of O1. Okay, so this intermediate signal also taking part in writing the program. So how do we declare the intermediate signals? So that is the next question. The intermediate signal can be declared using wire. Okay, the intermediate signal will be declared using wire. So it will not be available in the port list. So we don't need any IOs, input outputs not needed, because it is just an interconnection. Wire means just interconnection. That's all. Okay, it is used to connect from one end to another end. That's all. Okay, it will not be appearing outside. Just a connection. Okay, that is named as wire. Okay, so I'm going to write wire. So S1, T1, T2, T3. So these are all declared as wire. Okay. So one more thing, one more advantage is the compilers, if you didn't declare this wire, it will be considering it as a wire, those signal as a wires automatically. Okay, that is also done. But so while writing the program from the scratch, so have the habit of writing this. Okay, you should have an idea why we have written this S1, T1, T2, T3. These are all the intermediate signals. Okay, once it is done, next each and every gate has to be implemented using gate level modeling. Okay, so I'll write the syntax here for XOR. Okay, so you can write X1 as an instance name. First thing should be output followed by inputs. So you can write number of inputs here. You can write number of inputs here. It can be 1, 2, or it can be 3, or it can be multiples. But if you want to implement this XOR, how many inputs are there? 2 inputs, A, B. How many outputs are there? Only one output, S1. Okay, first implement this X1 XOR. So I'm going to write XOR. It is a keyword. Next instance name is the name which I have written inside. Okay, because for reference I have written. You can write any name which is following the rules of identifier. Okay, X1 within bracket. First thing I have to do is write this output. So what is the output of this X1? S1. S1 is the output. So output should be written at the first position. And one more thing is, while declaring input or output, if you declare any signal as input, it will only act as input. If I declare any signal as output, it can only act as output. But if I declare any signal as a wire, it can either act as a input or output. Both can be possible. Okay, if I declare any signal as a wire. Okay, S1 is my output. Okay, while considering this XOR gate, what is the output? What is the name written in the output side? S1. So I have written S1. So what is the input to this X1 XOR? A and B. So write A, comma B. So I have implemented the first diagram, first gate. Okay. Similarly, this gate X2 can be implemented. So I'll write XOR. So I'll write the name of the gate X2 as an instance name. And what is the output written here? For the X2, it is sum. So write sum. So what are the inputs to this XOR? We have S1 and Cin. So write S1, comma Cin. Close the bracket and terminate the line by using semicolon. Okay. So right now I have completed this and this. So next I need to find out what is A1, A3, A2 and O1. And while writing the program in gate level or data flow, the order of the statements are not at all important, because the simulator will treat, okay, all the lines, all the statements are executing at the same time, because it is a hardware which you are implementing. A hardware always work like that. Okay, everything will work at the same time. Okay, so your programming language also designed in such a way that it appear like all the statements are executing at the same time. Okay, it may be a 5 statement, 10, 15, 100, okay, any number of statements. All the statements will appear like it will be executing at the same time. So the first line XOR and second line XOR can be anywhere. So this can be written here also. Okay, the second statement can be written first. Okay, so it will be treating both the statements are executing at the same time. So this thing you need to understand, okay, while writing the program in Verilog. Okay, so next, so I have written next I need to write for A1. So it is an AND gate. A1 is an AND gate, so I'll use AND. So always use lowercase because all the keywords must be in lowercase. Okay, A1 is a name. Okay, what is the output of A1? It is T3. So write T3. What are the inputs to this A1? We have A and B. So A is one of the input and B is another input. Close the bracket, semicolon. Okay, next A3. So I'll erase there is this one, so that will be easy for me to continue a program. Sorry for the delay. Okay, now we'll continue. Okay, next is A3. Okay, next one is A3. So I'll consider this gate. What is the input to this? One of the input is Cin and another input is A. Okay, so I'll write AND. Okay, I'm just continuing the program here. So after this we have to come here. So AND. So I'll write the name of the device A3. The output is T1, comma A, comma Cin. Okay, A and Cin are the inputs and output will be T1. Okay, terminating that with semicolon. And next let us take A2. So AND A2. So output of this A2 is T2. And then what are the inputs? We have B and then Cin. Okay, Cin is connected and B is connected. So B, comma Cin. Okay, terminating that line with semicolon. Okay. And now I got T1, T2, T3. So this T1, T2, T3 should be given as an input to an OR gate so that I will get the Cout. Okay. So this OR statement can be written as a first line also. I told that the order of the statements are not important in the case of gate level or data flow. Okay. So OR. So write the name O1 within bracket. So the output of that is, output of this OR gate is Cout. And then input, the input is T1, T2 and T3. So T1, T2, T3. Close the bracket and semicolon. And the last line should be end module. Last line should be end module. Okay, the test benches are in your manual. If you wish to write, otherwise you just type this program and apply the inputs and see the output. How do we apply the inputs? In the case of full adder, we have A, B, C, 3 inputs. Okay, so in the truth table, I'll be having 3 inputs and 2 outputs, Cout and sum. So apply this input and run the program and check the truth table and verify the results. Are you getting the proper output or not? Okay, so this is how you have to simulate and see the results. Okay, thank you students.